So one of my very first reviews was doing a review on a little, I think it was either a 1 watt or a 2 watt power amplifier for Wi-Fi, and the reasons why I didn't like them particularly, and you know, the drawbacks of using one of those. Now I have progressed now and I've got almost 200 videos, and that particular video, the video quality was particularly bad. The sound was atrocious, but now I've got much better equipment to do a much better review and test, and I've been sent this one as well because I've been told that they have really improved over the last 3 or 4 years, and this latest one is pretty good. So I thought we'll take a look at this. I'll open it up first, take a look inside, and then we'll do some experiments on the network analyzer just to see how good it really is. So in the box then you get a dipole antenna. This is a 5 dB dipole antenna, and we can test that by having a quick look at that in a moment. You get a short pigtail so you can connect this to your router, and of course the amplifier. You also get a power supply, but I'm not going to use the power supply because it doesn't come with a UK plug attached to it. So it comes with this little adapter, but I just don't like these. They look particularly scary to me, and in the UK our plugs aren't perfect, but they are extremely safe, but this just does not look safe to me, so I'm going to use my own power supply. So first of all then, let's take the top off this dipole antenna just to see if it really is a 5 dB dipole. And without getting my ruler out, I can tell you with certainty that this is definitely a 5 dB design. It's got quite a hefty ground plane here. It's also got this section here, and I'm kind of guessing that this has been made for the amplifier, because the amplifier is putting out, you know, 4 watts, and you need an antenna to, you know, soak up a lot of that 4 watts. You don't want any of that coming back down the line because of a mismatched VSWR and you know, breaking the amplifier. So this is definitely a hefty little dipole antenna that's probably designed for the job of this little amplifier. So not bad, that's definitely got a tick from me. So before we do any testing and measurements on this little amplifier, I want to just take the cover off so we can quickly have a look at the circuitry inside, just so we can get an idea of what they're doing in here and how it's you know, splitting that send and receive up and managing to get that 4 watts along the transmission line. So I'll take these screws off here and then get the macro lens on so we can have a closer look. So I'm going to have to remove the warranty sticker to get into this, and this does come with a 12-month warranty card, and it's a return to China warranty, and they'll probably give you a replacement. But I'm wondering if anybody's ever done that. I've never done it personally because of the postage costs sending things back to China. So you know, if you've managed to get a good outcome with a 12-month guarantee on a Chinese product after the 45 days has expired on PayPal, so you can't use PayPal to back your corner, so to speak. Have you had a good outcome doing that? Have they actually honoured the 12-month guarantee? I probably think that they haven't, and probably ignored your emails. And that's the funny thing, I've just removed the warranty sticker and it's not even covering a screw, so I could have left it in place there. So the amplifier itself is a really simple design. So if we take a look at where the RF signal comes in, the RF signal comes in here, and then almost immediately it's split into 2 with this splitter here, and then the 2 signals are fed each independently into these 2 amplifiers here. So one half of the signal into this one, the other half into this one here, and then the signal comes out of there amplified, and then it's combined again here, and then it goes into the switch here, which is a little diode switch that switches between transmit and receive, and it does this really quickly. And then we've got the receiving signal coming out of the switch here, working its way down here, little transistor there, and then back and fed down the line. So it's really quite a simple design, and the specs, which we'll take a look at in the moment when I hook it up to the network analyzer, do give a little bit more power on the transmit side than the receiving side, and you can see why here now. There's not as much dedicated to the receiving side of things, but I'll hook it up and we'll see if the specs in the manual actually match up in real life. So to do the test then, I'm using the network analyzer, and I'm putting a swept signal into the little amplifier, and it's a really low powered swept signal, just enough to trigger the transmit side of this little amplifier. So it's going to switch between transmit and receive quite quickly, and I'm putting a swept signal in from 1 GHz up to 6 GHz. So then we should see a picture of where this little amplifier operates on the spectrum on the display of the network analyzer. So I've got the amplified peak displayed on the network analyzer. I am zoomed in quite far just to display it at its optimum size so you can see it here, and I am actually sweeping 500 MHz to 6 GHz, but you can see right on the edge of that peak I've got a cursor there, and it's displaying 2.45 GHz, so that's right bang on the money there. And I have had this amplifier on for a good 10 minutes, and there has been a small amount of thermal drift this way, but not a great deal, so definitely it works within its range there. So if I move the cursor to 2.5 GHz, and you can see there still on that peak, and I'll move it this way and we're at 2.30 GHz, so that's right on its peak. So you can't grumble at that. It's definitely within the 2.4 GHz range that we want to use this for, but it is quite broadband. I mean, the peak here, if we measure from here to here for instance, it still does quite a good job of amplifying in this area here if we ever wanted to use it for that. So if you ever wanted to use it for say 2 GHz, it'll probably do a half decent job. And the same on the other side here. If I move the cursor down a little bit, that's in the 3 GHz range. Again, it'll do a half decent job of amplifying a signal in that range as well. So as far as the amplifier working in the frequency range that is reported in the specs, it certainly is working. I mean, the thermal drift, I don't know if it'll get any worse. It's been, as I say, it's been working for a good 10 minutes, but it might be worthwhile just me leaving this here for another half an hour, just so we can check again on that thermal drift, because this little amplifier does get extremely hot. So as far as noise is concerned, you can see that there's a little bit of noise either side of this amplifier, and it's reported in the specs that this is FCC approved, and I can tell you that especially this spike here, this noise spike here, that's well out of the unlicensed range and into the licensed range, and just having that spike there, they would not get FCC approval. And as well as it being a 4 watt amplifier, it clearly takes it over the range you're allowed to do in this unlicensed band. Even though the band is unlicensed 2.4 GHz, there's still rules that you have to follow, and you know, 4 watts of power output is one of the rules that you're going to break. So you know, it definitely does not have FCC approval. And I've put the cursor right on top of this secondary noise spike here, and that's occurring right on the 1 GHz range. So I'm not sure what kind of products operate in the 1 GHz range, whether that's going to interfere with mobile phones or anything like that. I've kind of got a feeling that you know, some mobile phone carriers do operate in that range. So just having that noise spike there, you're not going to get FCC approval for something like this. And you know, as well as it being a 4 watt amplifier, of course, but that noise spike there is definitely concerning when it comes to, you know, are you going to interfere with anything else, you know, anything that you use or anything that your neighbours use, because it is a quite a big spike there, definitely protruding out from the side of the spectrum. So I've got the network analyzer set up then to take a look at the power curve of the amplifier. So you can see the curve here on the screen. I've got the cursor on 2.5 gigahertz, which is typically the frequency you'd use, especially for Wi-Fi. 2.44 gigahertz is probably the most used channel on the spectrum for Wi-Fi anyway, and we're getting an output power of 25.89 dBm. Now if you factor in the attenuator that I've got in line with this, it's a 10 dB attenuator, so we're looking at 36 dB of gain, which is about right for a 4-watt amplifier. So we're definitely in spec there from what it says in the spec of the amplifier itself, so I'm quite happy with that. So what I've done now then is I've turned the amplifier around in the circuit, and I'm now measuring the receiving strength of the amplifier, because we've got a 3 dB difference according to the spec between the transmitting power and the receive power of this amplifier, and that's pretty typical for an amplifier like this. Its receiving strength and its transmitting strength will never be the same. The receive strength will always be a little bit less, so it's measuring the receive strength at 15 dBm there. It's fluctuating a little bit, and then if we factor in the 10 dB of the attenuator again, we're getting around 25 dB, so a little bit less than the transmit power. The specs say 3 dBm difference, so again we're spot on there. 25 dB receive strength, and that's not too bad at all. You can't grumble at that really, so it's definitely receiving in the spec that it says in the manual. So as a final test then, I thought what I'd do is hook it up to a small router just to see how well it boosts the power of the router itself, because at the end of the day that's what this is really designed to do. Although you could use this for your quadcopter, let's say you just strap this to the back of your 2.4 gigahertz radio control unit, you'd get some more power out of that, some more range, and again you can use this with an alpha card in line as well with the antenna and boost that a little bit. But boosting a router is what it's actually designed to do. So what I've done, I've had a look in my collection of crappy routers, and I found this one, not the crappiest one I own, but this one was easy to put a external SMA connection on. Didn't take much time to do that. If you want to know how to do this kind of mod, I've done lots of videos in the past, so I've just epoxied it in the back there so we can give this a little test with the amplifier. So what I'm going to do is set it up first using this antenna that we get with the booster, because it is a little bit more beefier than the normal 5 dB dipole antenna. So we'll do a set it up and we'll do a scan to see how powerful this is transmitting with this dipole antenna on, and then I'll do a second scan with the amplifier powered on and in line, just to see what kind of increase we get from that. So I've had the scan running for a couple of minutes now, just to allow it to settle down a little bit. I'm just using the laptop's internal Wi-Fi card and antenna, and it seems to be operating around 60% to 62%, dropping out occasionally up and down, but definitely it's quite strong at 60% to 62% there. So what I'll do is I'll pause this, I'll go and add the amplifier in line and see what kind of signal improvement we get. So let's resume the scan then and see if we've improved that signal strength at all. So that's not too bad at all. It's definitely improved the transmitting strength of that little router by, you know, probably almost 30% there. Now it's settled down, and I haven't tested the receiving strength of the router, but the test on the network analyzer showed that there's probably about a 8% difference there in its receiving strength to its transmitting strength. But you know, that's a pretty nice signal there, so it does definitely boost the strength and coverage of the router. So I hope you found this interesting then, and I did enjoy making this. It you know, when you compare it to the one that I did over 3 years ago, it just shows how far I've come now with the test equipment that I've got. And the majority of the test equipment that I'm using now has you know, been purchased with the money that this channel's made, really. I mean, I've put some of my own money in, but the majority of it is the money that's come from this channel. So this little amplifier then seems to be a lot better than the original one that I looked at. I mean, it's a shame that I still don't have that original one, but I did end up using it on a project, and then it just went in a parts bin and it's gone missing. But this seems to be a lot quieter. It doesn't produce as much noise, and it's definitely doing the job in the range that it reports to work over. Definitely produces the dB that it claims as well, albeit it does lose a bit with thermal drift, and the longer you leave this on, it does lose about 4 dB of its transmit power, and around 3 dB of its receive power. So there's one other test that I really want to do with this, and that's to take it outside and really test it over a long range. Probably use something like a antenna and choose something that's well over a mile away, and see if we can use this to improve the the receive signal when we're scanning for, say, Wi-Fi networks, something like that. And definitely, if you were to use this with your remote control, for your quadcopter, it would certainly increase that range as well. But it has to be said that it comes with the caveat that this is definitely illegal to use in most countries. And something I've said about these previously, they're designed, as I say, to use in line with your router to get some more boost power coverage out of your router, but these produce a hell of a lot of heat. They really do. I mean, that's why it's in this heavy aluminium casing. And I've said previously, when people have asked me on different forums and things what I think to these, and to be perfectly honest, I wouldn't mind hooking one of these up for, say, a week, just to see if it's still running after that week, because I'm not confident that something like this would continuously work, when it's connected 24/7 to power. I really do think it'd end up burning itself out, and it'll have such a short lifespan. I can't really see it lasting very long when it's plugged in on continuous power. And as for FCC approval of one of these, it's not going to get it. I mean, these are used in professional setups, but they're licensed and approved prior to setting it up, just to make sure that it's not going to interfere with anything else. So it's only really for a professional setup. And although they've got the FCC logo on here, there's no FCC number, and all products that are licensed by the FCC, as in it's fine to use that product in your country, for instance, you would have an FCC number on here as well that you could check on the FCC database. So this is not approved by the FCC. And in, like I say, in most countries, although 2.4 gigahertz is unlicensed, it still has limitations, and a 4-watt power amplifier is it's just a no-no on that spectrum. So if you did enjoy this video, please give it a thumbs up. Any questions or comments, drop them below, and hopefully you'll join me on the next one.